maybe going back and taking a look at a problem that I think most people have already finished, but I want to start talking more about good design, good coding practices, and that kind of stuff. So we're going to take a look at maybe an older example and try to make it as pretty and efficient as possible towards the end of the day today. But first, let's talk about files and structs. So who can tell me, hang on. Okay, sorry. Who can tell me what hexadecimal is? Somebody explain hexadecimal to me? Yeah. Yeah. So we have 10 different digits, right? And the reason we have 10 is because we happen to also have 10 fingers and 10 toes. So it makes it easy for us as humans to think about things in terms of 10. Hexadecimal says, well, let's use 16 things instead. But we still only have 10 numbers. So how do we get up to 16? What do we do? Yeah. Yeah, so we start using letters. Once we get past number 9, we start using letters. So A is 10, B is 11, so on, so on, so on. Why do we bother? What's the point? Why are we using hexadecimal here? What's the big deal? Yeah. It's much easier for us to read than binary. Yes, absolutely. So binary is base what? 2. Binary is base 2, which means I've got 2 digits, 0 and 1, which works fine for computers. I mean, all computers use binary. It's great. It's a wonderful thing. We like binary a lot. But staring at those zeros and ones, I mean, I'm not Neo from the Matrix. I can't understand that stuff. So it's a little challenging to read binary. We can do it. It's just tedious and time-consuming. Hexadecimal, the advantage of hexadecimal is, so think of it this way, if I have a byte of information, how many binary digits are in a byte of information? 8, right? There's 8 zeros and or ones that comprise a byte. How many hexadecimal digits is that? 2. It's only 2. So that's a lot less stuff for us to have to decipher, right? 2 things is a lot easier to figure out than trying to squish all 8 of those digits together. So if we're examining files, if we're examining bytes in a file, hexadecimal is a lot easier to decipher for us than binary. Hexadecimal is one of those things, again, I've said this before, I don't like to tell people to memorize stuff. However, memorizing, the digits that correspond to hexadecimal, both in decimal and in binary, actually, I think, is useful. So if I look at you and I say, what's the value of D in decimal? I would hope that eventually you would be able to say, what is it? 13. And then I would also hope that you would be able to tell me what that value is in binary eventually, too. That's a little bit trickier, right? So what is 13 in binary? How do I say that? One, 1, 0, 1, that's right, 1, 1, 0, 1. The nice thing about hexadecimal, the reason it works so well, is that every hexadecimal value corresponds to 4 bits, 4 binary bits of information. So it's really just knowing how to count in binary up to the number 15, basically, 1, 1, 1, 1, from 0 to 15. So if you can do that in binary, then you can understand hexadecimal. And then you start to realize that a file is just a series of 1s and 0s that we can translate that way. Cool. How do we get information out of a file? Can we talk about a high-level approach? How do I get stuff out of a file? What's the first thing that I'm going to do? I give you a file, I say, hey, tell me what's in this. You're going to do what? You got to open it. And when we open it, what information do we have to provide? I'm sorry? Create a file pointer. What do we have to provide in order to create that file pointer, though? We can't just say, hey, create a file pointer. We have to give it some information, right? So what do we have to tell it in order to do that? We need a name, so we need to know the file name, and then what we want to do with the file, what are our options there? Read, write, and append are the big ones. So if we want to get stuff out of a file, that's going to be read, probably, right? Okay, so we open the file. That gives us a file pointer. Now what do? How do we get our information out of the file? Now that we have this file pointer. This is where we have some options. Quite a few options, actually. There's a few different directions we could go. So there's some functions that can help us out with this. I can think of at least 3 different functions that we could use to get information out of a file. Anybody tell me one? Yeah. fgets, yeah, that's how I say that one. fgets, sure. How does that one work? What does that one do? What information do I need to give fgets to do its job? See, now here's one of those things where I ask this question, but I would never expect you to just be able to memorize what that is. This is the point in the class. If you haven't been doing this already, I highly encourage you to keep the reference website open as you're working on stuff. You guys familiar with that? Reference.cs50.net. I don't remember what fgets needs. I've used it before. I've used it plenty of times. I'm going to use it again in the future. I'm probably going to use it today. But I don't remember what it needs. I have to look it up. That's part of a programmer's job, is knowing that sometimes you're going to have to go track down the information that you need to get the job done. So really, I mean, what does fgets do? Well, let's switch over and see if we can find it on reference 50. That's not fgets, that's something different. Here's fgets, maybe not. Oh, okay, sorry, I just can't read. So gets the next string from a file. What does it need? String s, int I, and a file pointer. So we already said that we had a file pointer, right? So this is the file pointer that we created with fopen. String s then is going to be where the results are stored. So that's where the actual information is going to come in. And then I is how many characters we want to read. But that's a little deceptive. It'll either give us I characters, or it might also stop at another point. What's another time that this might stop? Do you remember? Yeah. I'm sorry? New line, or the end of the file too, right? So if it's a new line or the end of the file, it'll also stop at that point. So we can use this to read in one line at a time if we need to, or a certain number of characters if we need to, right? This isn't the only way that we could approach this. There are other functions that can be used to read in files as well. Can anybody remember any of the other ones that we saw? Yeah. fopen, that's what we use to get the file pointer, right? So we're already beyond that step. fopen is a good one. What can we use to actually get information out, though, to read the data? Yeah. fread. So fread is another one that's similar to this, not exactly the same. What information does it need? Honestly, I don't know. I'd have to look it up, just like I had to look this one up. I'd have to go type in fread and see what it needs. So you see it's got a pointer, size, blocks, file pointer. So fread is a little bit more complicated, than fgets. But in traditional, programming way of doing things, there's always going to be multiple ways of accomplishing the same task. There's also fgetc. What does fgetc do? Just gets one letter at a time. So that might be, require a bit more effort. I'm just reading in one letter at a time. That might take a little bit more work, but it'll get the job done. Which one should you use? I mean, for the most part, it's whichever one you feel the most comfortable with, right? That's the correct answer. All 3 can usually get you to where you're going. It just might be that one's a little bit better at a particular task than another. And that's sort of what I hope to give you a feel for when we do some practice problems, and in the prep work as well, actually, if you did the prep work for today. All right, cool. So we've opened the file. We've chosen one of these functions to get data out of the file. What's left? What do we have to do then after that? Say we read in what we need. We found what we wanted. Everybody's happy. Yeah. We have to close it, right? We have to close it. We have to call fclose. You can think of fclose as being somewhat similar to freeing memory, right? Or telling the file pointer that it's safe that it's safely closed, that we don't need it anymore. we're not going to be reading anything from it. So how do we put information into a file then? What's different about the process we just talked about? Some things are the same, right? Some things are different. Yeah. Yeah, so when we open the file, we need to tell it that we're going to write to it. Usually W will work. A is also an option that we can use. But we need to tell it that we're going to be writing to the file. And then what? What do we do after that? Now we can't use fgets. We can't use fread anymore. What are we going to use instead? Fputs or fwrite is another option, right? So again, just like we saw with reading, we've got some choices. We've got some choices as to how to write our data out to a file. Which one should you pick? Whichever you feel most comfortable with is the best answer for now. And then just like we did with writing, in fact, perhaps even more important with writing than with reading, we need to make sure to close the file at the end. If we don't close the file when we write it, there's a chance that the stuff that we've written to the file won't actually make it to the file. With reading, it's less of a problem because we're not changing anything. But with writing, it's particularly important that we close it. Otherwise, we might lose some data. Good. Are there any questions about hexadecimal or files before we talk about the next one? Okay. What's a struct? Can somebody describe a struct to me? What's a struct? Yeah, go ahead. Yeah, so it allows us to take multiple elements and then kind of wrap them all up in a nice package, right? So I can stick ints in there, or booleans, or strings, or actually even other structs. I can have structs inside of structs. That's okay. I can do that. So what's the point? Why do we do this? What are structs used for? What's the big deal? Yeah. Yeah, so structs are stored and used just like variables are, right? So essentially, when I'm creating a struct, when I define a struct, in a lot of ways, I'm actually defining my own customized data type, right? When we declare a variable, the first thing I have to say is, what's the type of this variable? By creating a struct, I'm essentially saying, well, I've got a new data type that I want to use, and I can use that then as a type for a variable, and then treat the struct as if it were any other variable, really. It's a little bit different than other variables. It's a little bit different. You know, this is kind of getting to these questions down here. How do we use a struct? So it's not just enough to refer to the structure itself. If I really want to get information out of the struct, what do I have to do? A struct doesn't just have one piece of information in it, right? It's got multiple pieces of information. So how do I get one of those pieces of information out? Yeah. Yeah, we have to use the dot operator. That's one way. There's actually another way. What's another way we can do that? There's an arrow operator. You guys remember seeing that? An arrow operator. What's the difference? When do we use dot? When do we use arrow? What's the difference? This is one that people often struggle with when they first see structs. What's the difference? What did we talk about on Tuesday? What was the main topic on Tuesday? Pointers. Oh, yeah. You were hoping we wouldn't bring that one up, weren't you? Yeah. But I can have pointers to structs, just like I can have pointers to other things. So if I have a pointer to a structure, which am I going to use, the dot or the arrow? The arrow. The arrow. If I don't have a pointer to a struct, if I have the actual structure itself, I can use the dot, right? Use the dot to access the values. That's important. And we're actually going to see some examples of that today. Cool. So structures, we still didn't quite satisfactorily answer what they're used for. What are structs used for? What's the big deal? Couldn't I just create a whole bunch of variables and just do stuff that way? Can you think of any reason why we might want to use a struct instead of just creating a whole bunch of variables to do the same thing? Less code to write, sure. Yeah. Maintenance, sure, yeah, that's a great thing to mention. So I keep all that stuff in one place. I don't have to go searching around for all the different pieces. It's just in one easy to access place. There's some limitations that we've run into with certain constructs. For example, how many things can I output from a function? One, just one thing. I bet you've probably run into a case where you're like, man, I really wish I could output 2 things from this function. Well, guess what? You can make a struct that has 2 things in it, and then return a struct, right? So now I actually can output multiple values from a function if I want to, using structs. That's a pretty convenient thing to be able to do, right? We're going to see some stuff like that earlier today. I can pass structures into functions, and that's equivalent to passing multiple values in as a single variable, instead of having to type out all those variables in my function definition, right? That's a nice thing to be able to do. Nice thing to be able to do. Any questions about structures before we try some practice problems? Let's try some exercises. No? Okay, we're actually going to start with structures. We're going to build some structures today. Before we do, let me introduce you to my cat, Franklin. He's a wonderful cat. He's very orange. He's very soft. I love him very much. He's kind of obnoxious, but what cats aren't. So what I want to do first today is actually define a structure for cats. We're going to make a cat structure, which I know is pretty groundbreaking, pretty revolutionary. That's what we're going to do. So I want to define a structure that represents a cat, right? So how am I going to do that? How am I going to go about defining a structure that represents a cat? The first thing that I'm going to do is ask myself, what are some attributes about a cat that I would like to remember? So who can tell me some properties of a cat? Yeah, their name. Most cats have a name, right? Except for that stray cat that lives in the alley that I just say, hey, you. So a name might be a good thing to include. What else? What are some other properties of cats that we might want to remember? Yeah. Breed? Okay, sure. Why not? What else? Age, sure, yeah. That's a good one. What else? Color, yeah. Any others? Weight, size, temperaments. Wouldn't that just be, mean, obnoxious, surly, self-centered? Yeah, I could go on. What do you notice about these things that we're shouting out? All great suggestions. They're all nouns, right? They're all things. They're all physical. Well, maybe not physical, but they're all, objects. They're all things that we're using to describe this cat. So when I'm defining a structure, the things that go inside of a structure are going to be nouns. They're going to be things that describe the overall structure that I'm talking about. So if we're talking about a cat, right? Name, age, breed, hair color, things like that are great examples of things to put into a structure. So let's start to put this structure together. I'm going to go over to my IDE here and start creating this cat structure. So let's see, I'll do this right here. I'm going to create a new file. Actually, I haven't done this in part of the review session yet. I wanted to do this today. I'm going to create a new file. I'm going to put this structure definition in a header file, just because I can, mostly. So I'll call it cat.h. I'm going to do this in a header file. I've been meaning to review header files with you for a while. Now I've got a good opportunity to do so. So I want to define this cat structure. What do I need to start typing in to define a structure? Somebody help me out here. What kinds of code do I need to start typing in? Type def. That's the first thing. What comes after that? Struct, okay. And then what? Curly bracket, all right. And then inside the curly brackets goes what? That's where we define the properties, right? The things that we want this structure to contain. So the things that we just talked about. So if I want to define a property for the name, right? What am I going to type in here? What do I need to know in order to define a name property for my cat structure? String, so it needs a type, and then what? Just the name for it. So string name. Do I need a semicolon? Yeah. One down, right? So I can keep going. I can keep adding properties. I'm just going to do a few of them. Let's see. I'll do int age. I'll do, cats have 9 lives, right? So int lives. String, oops, color. I'm just going to do those. If you want to do different ones, then it's your cat. You can create it. There's more than one way to create a cat struct, right? Go ahead and construct a cat to whatever specifications you would like. What do I need to finish this off? Let's say I'm satisfied with this. Am I missing anything? I need a semicolon at the end, but I also need to name the structure, so I'm going to call it cat. I put it in all caps. I think it can be good to keep your structure names all caps so that you know it's a structure as opposed to just a regular thing, a regular data type. Not strictly necessary. If you wanted to call it cat, I wouldn't be unhappy with it. I'm going to call it cat, all uppercase. Okay. Yes, but like, it is a convention, but like most conventions, people can never agree on them, so, you know, like I said, I'm not going to be too picky about it. Okay, so we've got this wonderful cat structure. So I want to try and do some things with some cats. I want to try and create some cats. So what I'm going to do is I'm going to create another file. Maybe I'll call it cat.c. And in this file, this will be the file where I actually create some cats and do something with these cats. I'm not sure what yet, but let's go ahead and get this set up for us to start doing some things. We need our usual includes at the top, right? So we probably need standard.io.h. We probably need CS50x. Just guessing, maybe not, but better safe than sorry. Probably going to need a main method of some sort. So I'll go ahead and toss that in there just to kind of get us rolling. Yes? Ah, yes, that's a good call. We should include strings since we do use strings in our struct. Am I missing anything else? Yes? I'm sorry? We need to include the header file. Good. I was waiting for somebody to suggest that. So I need to include the header file. So this is right? No, all right. What do I do? Quotes. So I've gotten asked this question before, actually. When do I use quotes versus angle brackets? Can anybody explain that to me? I'm sorry? Quotes if the other file's in the folder that I'm currently in. Yeah. Another way of thinking about it that I've heard somebody mention is, you know, if I created this header file, it's probably going to go in quotes. If it's a header file that was given to me from the C library or the CS50 library or some other library, then it's probably going to be angle brackets. That's a good rule of thumb for deciding whether to use quotes or angle brackets. But I need to do this. In order to be able to create these cat structures that I want. All right? All right, let's take a look and see what I've got next up on my list here to talk about. So I think I've got some exercises with some cats for us to take a peek at. So the first exercise wants us to actually, wants us to create 2 cats. So I want to create 2 cats. I want to create one cat just as a normal variable, and I want to create another one as a pointer to a cat structure, right? So I want to create 2 cats. I actually do have 2 cats at home. You saw Franklin already. I also have Sally, who is, I never see her. She hides under the bed all day. Poor Sally. She's a good cat, though. So let's switch back over to the IDE. And before I turn you loose on this, let's talk about a couple things. How am I going to create these cats? I need two of them. One is a regular variable, one is a pointer. So let's start with the regular one. How am I going to create this guy? Any suggestions? I need to create a new variable with type cat. So cat is my variable type, right? And I'll name this guy Franklin. And then when I say equals, I need to set the properties that Franklin has, right? I need to give him the properties that we had in the struct. He had a name, he had an age, number of lives, and what was the last one? Color. So how do I do that? What do I say here? How do I actually set those values? Yeah. I can use curly brackets to do that and start typing in the values. So Franklin, in the same order that they appear in the header file, right? So name came first, so I typed name first. Franklin, age was next. Franklin he's like 9. He has 9 lives, and he's orange, very much orange. So there's one cat down. Now the next one I'm saying I want to be a cat pointer. I'll make this one Sally. Since it's a cat pointer, what do I have to do differently here? This is where things get a little tricky. This is where things get a little tricky. Yeah. We have to allocate memory for it. So we do that how? Malloc. Good. Malloc. Oops, forgot an equal sign. Malloc, and then inside the parentheses, we're going to say what? Size of cat. And now if I want to actually set the values for Sally, this is kind of where I'm going to turn you loose, actually. We need to give Sally these properties. We need to set these same properties for Sally that we did for Franklin, right? We need to give her a name, an age, a number of lives, and a color. So we need to do that here. I've also got a couple of other problems for you to consider once you've got your cats created. I want you to create 2 functions that both accept cats as inputs. So one function is, they're going to do the same thing. They're going to take a cat in as input. They're going to say, something like Franklin says meow or something like that, right? Just print out the name of the cat that was passed to you. It's a very simple function, very simple function. But I want one of those functions to pass the cat in by value. And I want the other function to pass the cat in by reference. I want them to do the same thing, but I want one to be passed by value. I want the other to be passed by reference. And you should test them with both of these cats that you created. So this is where I'm going to pause and give you 5 or 10 minutes to, pun not intended, although I wish it was. Give you some time to work on these problems. So actually, let me go back to the IDE and write down what I want you to do here. So set properties for Sally, 2 functions that print name of the cat, one passed by value, the other passed by reference. These are what I want you to work on for the next, let's say 10-ish minutes or so. I'll be wandering around if you get stuck, if you have any questions, if you want to ask me about my cats. I've got some mentors who will be around to help you out as well. Alrighty. Let's start to piece this one together. The first thing we need to do is finish setting up Sally. So how do I start setting properties of Sally? If I want to set Sally's name, what am I going to type in here? Somebody help me out? Sally arrow name. Why arrow instead of dot? It's a pointer. It's a pointer to a cat, so we should use the arrow operator. Equals Sally. And I can do the same thing for the other ones, right? Sally age. Sally's Sally lives 9. Sally color, and she is a calico. Oops, not a Salico. Calico. That's fine. Whatever, that's fine. Okay, so Sally's been finished up. Now we have this business of creating functions. I want to create 2 functions. I purposefully didn't go through the function definitions with you here. Let's talk about that right now, actually. I want to create 2 functions, both of which do the same thing. One of them is going to accept a cat as a value. The other one's going to accept a cat as a reference. So let's start to piece these function definitions together. What's the return type going to be? Void. These are going to be real simple functions, probably one-liners, really. Void. Next thing is the name, right? So I'll call it meow. And then inside the parentheses, if I want to pass a cat by value, what do I say? I say cat, and then I can call whatever I want, right? Just give it a name, kitty. All right, there's one function defined. I'm not going to fill it in right now. Let's do the second one real quick, actually. I'm going to create a second version of meow, call it meow2. I know it's so creative. Now I want to pass in by reference. How do I pass in a cat by reference? Cat star, good. Cat star, and there we go. Okay, now we can talk about what we want these to do. In both cases, we want these functions to pass, or to print out the name of the cat, right? So I'm going to need a printf statement. The name is a string, so %s should do it, right? Says what do I put in here? How do I get the name out of this cat? How do I get the name out of this cat? What do I type in to get the name out? Kitty.name. I use dot here. Because we actually have the copy of the cat, right? We passed in by value. That means we actually have a copy of this cat to use. Let me stick a new line on the end. Let me stick a new line on the end there. So then if I come down here, I can do almost the same thing, right? I can actually take this line of code and just copy it into my second one. And then instead of kitty.name, because I'm using a cat pointer, I should be able to just switch that to the arrow and have it do the same thing, right? I'm going to change this one just a little bit, just so that we know whether we're in the first one or the second one, just so we can tell. Just so we know. Okay. So I now have 2 cats, well, I do have 2 cats. I also have 2 functions that accept cats and make the cats meow, prints out their names. Right? I want to try and use both of these functions with both of the cats that I created. That's sort of my next step. Oh, before I forget, I probably need the prototypes. I always forget the prototypes. I always forget those prototypes. So I need those. Let me go ahead and put those in before I forget to do so. All right, so let's start with our first function. Let's start with this function that passes by value. Right? If I want to use this first function with Franklin, how do I call the function? What do I have to do? How do I call that function that passes by value with Franklin? What do I have to say? Yeah. Meow Franklin. It's as easy as that. Not really anything different than the way we have been doing it. Because Franklin is an actual cat object, and this wants an actual cat object, so they match up. Everything matches, and we're good. What if I want to do the same thing, use the same function with Sally? How do I do that? Ampersand. I have to use the ampersand. Why? What's the ampersand operator do again? So it follows the address and gets the actual thing that the pointer is pointing to, right? What do we call that in computer science lingo? It's dereference. Good. Dereference. All right, let's try this out. We haven't tested any of our code yet, which makes me nervous. So let's try this out. I am in the wrong directory right now. So let me get to the right directory. Module 4. I think we're in lecture. All right, cool. Now I need to make cat. Oops, except for I need to save. I need to save. That's what I need to do. All right, let's try that again. And what did I do wrong this time? Oops, no, we did something wrong. So we're passing cat stars odd, so we used the wrong operator. Ampersand Sally didn't cut it. Ampersand Sally didn't cut it. Why not? It's giving me the address. Yeah, so we got it backwards. We got it backwards. I fell for it too. So it's giving us the address of Sally, but Sally is already an address. Sally is a pointer. We want the opposite of that, so how do we do that? Star, right? Let's try that one and see if that makes it feel a little better. All right, we compiled that time. That's good. And now if we run cat, they both meow at me. Good. Feels like I just walked in the door at home. All right, so that's the first function. Let's talk about the second one now. I want to try and use this second one with both of these cats too. So let's start with Franklin. I want to use meow too. Oops. Come on. With Franklin, so how do I do that? We kind of already discovered this one, yeah. Now we need the ampersand. Yep. We need the ampersand for Franklin because Franklin is the actual thing, right? But this function wants a reference. This function wants an address. So I use the ampersand to get me that address. What about with Sally? Do I need to do anything with Sally? Anything special? Sally is already an address. Sally is already a pointer, which is what that function wants. So that's okay. We can just pass in Sally directly. Let's try it one more time and see. All right. You can see that it works. You can see that it works. Okay. Oh, that's much better. See a lot more stuff. I can think of at least one thing that we're missing. At least one thing that we're missing. Does anyone know what that thing is? Yeah? Yeah, we called Malik. We called Malik. Anytime we call Malik, there should be a corresponding call to free. So I need to free Sally. Open up the front door and just let her go. Sally wouldn't go out the front door even if you let her. She would cower under the couch. So I'm not too worried about freeing Sally. But yes, we do need to give that memory back. We need to give that memory back. Do we have to do that for Franklin? No, we didn't allocate the memory for Franklin. Why not? I mean, that was already taken care of for us, actually. Right? When we created Franklin this way. Cool. I think we're done with this little exercise. Are there any questions? Yes. So doing it all in one line, you mean, basically? To my knowledge, no. I have to call malloc, which is its own separate thing. Since it's a pointer, I have to. Not to my knowledge. Now, there might be some that I'm just not aware of. The Google might have a better answer to that question. It's a good question. I personally do not know of any better way than this to do it. It's a good question. Yep. Any other questions that I can answer about this particular exercise before we do something else? Do something different? Okay. Wow, it's almost 6:30 already. All right. We're going to shift gears a little bit then. I do have some exercises about files. I'll post these. I would encourage you to take a look at them. There's really just, I guess it's just the one exercise about files. I would encourage you to maybe try this one out if you have time to do so. There's also a lot of exercises in the prep work about files. That is intentional. You need to use files on PSET 4, so that'll be good practice for you. But what I would like to do right now is actually kind of back up a second and take a look at one of the studios that we've already done. The WordGrid studio. I want to take a look at that studio and talk about design a little bit. So I'm hoping that most, if not all of you, have already completed that studio. If you haven't already completed that studio, you may want to, there's some major spoilers coming up, so you may want to, move somewhere else or ignore me for the next half an hour. What I would like to do is, A, take a look at the solution, make sure we understand how it works, but then also talk a little bit about how can we make it look good, how can we make it as efficient as possible, and just talk about some general design strategies for writing code. As we get into more complicated things, that becomes much more important, and actually, starting here pretty soon, we are going to be grading your PSET submissions for style, basically, for design, and giving you some personalized feedback on those kinds of issues. A lot of you have already asked me about it, which I think is great. I love hearing those kinds of questions, so please don't stop doing that. That's actually kind of what inspired me to do this little exercise today. So let's take a look at the solution to WordGrid. Just to give you kind of a refresher, let me show you how it works first. So that I know it's been at least a week since we took a look at this. So let me run it for you once and kind of give us a refresher of how it works. It was a studio that we did in Module 3. So if I run WordGrid, I have to give it 3 command line arguments. Son, cat, boy. And they all have to be 3 letters, right? This is kind of sounding familiar. 3 words, 3 arguments, all of them are 3 letters. And then when I run it, it takes them, it rotates them, and prints it out going vertically instead of across, right? You guys remember this studio? Good. So let's take a look at the solution first and then talk about some good design for these kinds of things. So here's my solution. The first thing, the problems that the studio actually suggests that you do is you do a little bit of verification. You need to do a little bit of verification. We want to make sure that they entered in 3 arguments, right? So here I'm checking to see if argc is not equal to 4. Wait, didn't I just say 3? Why 4 then? Yeah. The name of the program is the first one, right? So argc needs to be 4. If they didn't give me 3 words, then I want to stop them and tell them to give me 3 words. Okay. The next step then is we want to ensure that all of the arguments that they gave us are 3 letters long. So if they give me something that's too short or too long, I want to also stop and be like, hey, I need words that are 3 letters long. In fact, if I try this like so, so it tells me that, but so I found a bug. Good. I found a bug in my code. What's the bug in my code? I forgot to return. So this loop here is doing the check to make sure that all of the words are 3 letters long. How does it work? I actually skip the first one because that's the program name, right? So I start with the second argument, that came in. I check to see if the string length is not equal to 3, I print out this message that says, please enter words that are 3 letters long, and I should have then returned here, which I forgot to do. Let me try to remake this and make sure that that bug is fixed. Word grid, sun, cap, yeah, there we go. That worked. That worked. So we do a little bit of verification first, right? Make sure that they give us the right amount of words. We make sure that the words are all the appropriate length. And then we need to do the work. We need to get to the actual job that needs to be done. So that's what these loops down here do. You can see I've got a printf statement, right? What does this first loop represent? What am I looping over with this first loop? What am I using this first loop for? I'm sorry? Line? Each row? So if I'm thinking about the arguments that are coming in, if I'm thinking about the arguments that are coming in, what part of the arguments is this loop dealing with? Which part? It's going to be each letter, right? Does that make sense? So the first time this loop runs, it's going to operate on the first letter of each word. The second time it runs, it's going to be the second letter, and then the third letter. How do I know that? What's my clue? How do I know that? I mean, the problem specification demands it. The solution to the problem demands that we do it this way, right? But if I look down here, you see that I've got I in the second position. I've got I in the second position, which is referring to letters, right? Referring to letters in the words. The first position is referring to the actual words themselves, right? So this second loop then is doing the words. So the way that I interpret this loop structure is saying, for each letter in each word, print out the first letter, then print out the second letter of each word, then print out the third letter of each word, right? Which is what we need to do in order to get the desired effect. Does that make sense? Are there any questions about this approach, about this solution to the problem? Okay, so let's talk about design a little bit. I guess for starters, I have some things about the way, so I wrote this code myself before class today, and I have some problems with it. I have some problems with it from a design standpoint. From a functionality standpoint, it's perfect, right? It's exactly what we asked for. I can't complain about how it works. But from a design standpoint, I have some problems with this code. So can somebody suggest what some, some design problems might be that we could take a look at here? Yeah. 4 and 3 look like magic numbers. Good. I'm glad you used the term magic numbers. What's a magic number? What's a magic number? Is that a term you guys have seen around before? Yeah. Yeah. So they're hard coded in. Yeah, that's the real way to think of a magic number. Where did I get 3 from? I don't know. It's magic. I just pulled it out of the air and I put it in, right? That 3 has a meaning though, right? 3 has a meaning. What is the meaning of that 3? Why is it 3? What's 3 represent? Number of letters, really, right? Because remember, this loop represents letters. This loop represents letters. The number of words and the number of letters in this case are actually the same. We want them to be equal in this case, but this loop in particular refers to the number of letters, right? And then this 4 down here is a similar magic number referring to the number of words. We have the unfortunate problem that we have to start with 1 instead of 0 here because of that first argument. So we have to kind of shift ourselves up 1. So we have to take that into account, which makes it a little bit sloppy. But how do I fix this problem? If I want to get this 3 out of here and this 4 out of here, what do I do? How do I fix it? I'm sorry? The 4 could be replaced by argc. That's a great suggestion. The 4 could be replaced by argc because I want to loop for every argument, right? I want to loop for every argument. So that's fine. That's perfect. What about the 3? How do I get that one out of there? Yeah, way in the back. I could just do the string length of argv1, and I know that that will work because I've already verified that those lengths are what I want, right? I already know that all the lengths are appropriate, so I could do that. One way of doing that would be like this, strlen argv1, right? This still, to me, honestly looks a little bit clunky. I actually would prefer, from a design perspective, to maybe create a variable with that guy, and then refer to the variable inside of there. But we could even perhaps simplify it even more. We know that it's going to be 3 every time, right? We know it's going to be 3 every time. So why even bother taking the length? We know that we want it to be 3. In fact, we have that same, this is another magic number, right? That's another magic number. So why don't we just define it as a, just say right at the top, num letters equals 3. I know that that's what I want. I can even stick a comment in here that says we require 3-letter words, right? Just to explain what that's for. And then anytime that I need to, down here, I can replace this then with num letters. Actually, this number 4 right here could easily be replaced by argc, just like we did below, right? That's better. That's more descriptive than the number 4, right? We've already verified that argc is the value that we want, correct? And actually, well, I'm doing too many things at once here. Let me finish my train of thought. Actually, so we've got num letters in there. That's good. We've got argc here. What about this number 4? Can I do anything with that? Well, we know we want 3 words, right? We want 3 words each that have 3 letters. So I know then that I have to accommodate for that first argument being the program name. Couldn't I always reference this as num letters plus 1? Is there anything wrong with that? Is that okay? Question? So I like this question. So we've actually got 2 values here. We've got number of words and number of letters, but we know that they're going to be the same. So maybe instead of calling this num letters, we should just say number, it's both, right? It's the number of letters and the number of words. So couldn't I just use the same variable to represent both? Just maybe name it a little bit more carefully. Number of things, I don't know. Anybody have a better name? Dimension might be a good name, right? Kind of reminiscent of the magic 15 problem that everybody loves. So dimension might work. But now, unfortunately, you can see I have to go back in here and rename this guy, which you can, find replace is your friend. Find and replace is your friend. If you're not familiar with find and replace, you can hit Control F on this screen and search. I want to search for num letters. And then there's a replace thing down here. I want to replace it with, what did I call it, dimension? And I'll say replace all. And you can see it, instead of me having to track down where I use that variable, it tracks it down for me and replaces the name of that variable for me everywhere that I want. Find and replace is seriously one of the programmer's best friends. Yes? Yeah, so last week you guys learned about pound defines in the advanced C discussion. That would also be an acceptable solution. We could define it as a constant at the top of the file, absolutely. I'm going to leave it like this for now. I don't see a problem with doing it this way. Pound define, of course, would be a perfectly acceptable solution as well. What flexibility does that, so imagine now, so we've made these changes. I like these changes a lot, as a matter of fact. Just to illustrate the flexibility that now grants us. Everything right now is based around the number 3. Well, it doesn't have to be now. If I want to change my mind and talk about 5-letter words, I just change one value right at the top of the file to the number 5, and now this same program should work with 5 words that have 5 letters, right? Right? It should. Let's try it out and see. I need to make it first. Save it. Make word grid. All right, I need 5 5-letter words. You guys can help me out. We got some smart people in this room, right? There. I'm sorry? Enter. What was that? Loops. I like that one. Happy cats. I got, oh, that's 5. Okay, good. Sorry. And it works. It works. We changed one value of one variable, and now our program adapts to that new value. That's great. That's good design. Before I put those variables in there, I have to go find those numbers all over the place, right, and change all of them individually. That's a pain in the butt, right? This is good design. This is good design. Any questions about that? Oh, yeah, so we would have to update. Yeah, actually, let's talk about that. Great, I'm glad you asked. This comment still says, please enter 3 words. So if I don't enter enough words, it's still going to tell me to enter 3 words. Can I fix that? What's a good design way to fix that? I can use that variable here too, right? I can use that variable here too. I can replace this with %i and then slap that variable right in this message. Perfect. Do I have another one down here? Yeah, I sure do, right? %i, right? Perfect. And now if I make a mistake, it should, oh, I need to remake it. It tells me to enter the appropriate value, right? That's great. That's great. Cool. Any other questions, comments about what we've done so far? We're not done yet. I got more. But wait. Any questions before I do next thing? So something else that I would like you to start thinking about, especially, you probably noticed that the programs we've been writing have been getting larger, right? More complicated, more code, more files, more stuff. One thing that I would like you to start to sort of become conscious of, everything in this particular program right now is in the main method. Everything, right? The main method is the program. As you start to build larger programs, as you start to build more complex programs, you should really get out of the habit of just dumping a bunch of stuff into main. Main should be the control room. If this was an episode of Star Trek, right, main should be Captain Kirk, who's yelling at the different people to do the tasks for him. That's the role of main, right? So I don't want to see a whole lot of heavy lifting in main. What I'd really like to see in main is a series of function calls. Those are the main methods that I like to see, right? So creating functions out of stuff is another great skill to learn, another good design habit. Can you kind of visualize where we might use some functions here? Anybody have any ideas? Yeah. So the validation, I think, is a great thing to go into a separate function. Why not? The validation stuff is a great thing. That's 2 pieces, right? We've got the number of words as well as the number of letters that could be moved off into a separate function. Let's try it out. Let's try it out. So we're going to create a function. First part of a function is the return type. So we already have some thinking we got to do, right? This function is going to validate that we have the right number of words and the right number of letters. And then it's going to need to tell us either, yeah, we're cool, we got the right amount of stuff, or no, we got problems, right? Things are bad. So what return type might work for this? Yeah. A bool. A bool's perfect. Either it works or it doesn't, right? It does what it's supposed to or it doesn't. So a bool is a great return type. We can call it validate, I suppose. What information is it going to need to do its job? So it's going to need argc and argv. I don't necessarily have to call them argc and argv if I don't want to, but I could. I mean, there's nothing wrong with that. So, I mean, really, I can kind of steal this guy, right? If I want to, and slap that in there. What else does it need to do its job? Yeah. It needs the dimension, right? I have to know how many of the thing that I'm looking for. Dimension. Oops. Oops, I forgot something else, even more important. And so what's this function going to do? Well, a great way to create functions is to just grab the stuff that you want and slap it in there like this, right? Take this, boom. And then what am I going to do with this stuff up here? This stuff that I copied. I don't need it anymore, right? What am I going to do instead? I'm going to call the function. Call that function. So I need to create a function call. We called it validate. I need to pass in the appropriate values. We said argc, argv, dimension. And then I need to interpret the results, right? This is going to give me back either a thumbs up or a thumbs down. You see? So I need to check that. Actually, I forgot to put that down here, right? It says return 1, return 1. Is that good? That's not really what we want. What do I want to return here instead? False. It failed. Same thing here, right? False. It failed. Yeah, good. Good. At the very end, so I like to think of these as kind of like a gauntlet, right? If I pass this test and I pass this test, then I get the thumbs up. So at the very end, I pass the gauntlet, everything's good, so I give you the thumbs up. I say return true to indicate that, yeah, you made it. You passed the test. You passed the test that I laid out. And so now, this guy up here is going to be returning either true or false. What am I going to do with that information? What do I need to do? Yeah, go ahead. If it's false, I need to get out of here, right? If it's false, I need to abort and get out of here. So if there's a fast way of saying this, not return 1. Notice validate returns true or false, right? If it returns true, this exclamation point is then going to do what? It's going to flip it and make it false, right? Which will skip the if statement. If it's false, if it returns false, then the exclamation point will flip it and make it true, which means that I'm going to stop. Yeah, I know it's a little confusing. But this is also good design. If you want to create a separate variable and do it that way, by all means, I would not stop you from doing such a thing. But this is pretty common practice. Take a function, and if I'm looking for the opposite, the false value, then slap an exclamation point out in front. Let's test it. Let's test it. Prototype, thank you. I always forget the prototype. That is my main weakness. All right, let's see if I forgot anything else. So we want to give it something that's going to fail. I mean, really, that's easy, right? Please enter 5 words. So I did enter 5 words, but what if I enter 5 words that are the wrong length? Please enter words that are 5 letters long. It behaves exactly the same way as it did before, right? The functionality has not changed. We changed the code, but the functionality itself did not change. We actually have a term for that. Computer science? Anybody remember? See what that's called? It's called refactoring. It's actually a very important part of computer science. The idea behind refactoring is this. The first time I write a program, my main goal, honestly, is to just try and get the darn thing to work. I'm sure you've all been in that space before. You don't care how you get it done, you just want to get it done, right? But the result, the code that you end up with, if you're just trying to get it done, is probably not the most beautiful code in the world. Probably not something you'd want to show off to people. Wouldn't win any code beauty pageants, right? So then once we get it working, we can refactor that code. We can go back and we can update our design, just like we're doing right now. We can update the design, make it a little bit better, make it a little bit easier to read, make it a little bit more efficient. But if the behavior remains exactly the same, Refactoring means rewriting code without changing the overall behavior of the code for the purposes of efficiency or readability, right? Making your code look nicer. That's exactly what we're doing right now. It's refactoring this code. Cool. So that's one function. I think we could do one more if we wanted to. Okay. We could create another function for this stuff down here if we wanted to as well. And I think we should. So let's do that. I'm going to create a second function. What do I want the return type of this guy to be? It's going to be doing the, making the grid. So what's the return type? What's a good return type? Void. We have to name it. I'll call it what? Like print grid. What information is this function going to need in order to do its job? What does it need? Basically the same stuff, right? Basically the same stuff. This stuff that we have up here, it needs to know the same information. And then, just like we did last time, I'm going to go find this chunk of code that I want up here that prints out the grid. I'm going to take it, I'm going to get it out of my main method, and I'm going to plop it down here in my function. And then up here in my main method, all I need to do is make a call. Print grid, rc, rv. And then I also need to prototype. I'm not going to forget this time. And now we can try one final time to try this out. Let me try one that works. So this one should work, right? 5 words with 5 letters apiece, and it does. So we've successfully refactored our code yet again. And let me show you the finished result. What I see now in my main method is a very short amount of code. You can see main method. What should it really do? It should provide you a high-level look at what's going on. And using functions allows us to do that, right? I see the first thing that I'm going to do is try to validate. And then I see if validate succeeds, I'm going to print out the grid. That's a very high-level description of what I want this program to do, right? That's how I would prefer my main methods to work. They should be kind of a high level. They should be, controlling the strings behind the scenes and letting the functions themselves do the heavy lifting, do most of the work, which we see down here. This design provides some other advantages. I guess before I launch into that, though, are there any questions about what we've done so far? Any questions, comments? So there's one final thing. We've got a few minutes left. One final thing I want to talk to you about. Another good piece of design is really trying to keep things as general as possible. We really want things to be reusable. So specific things are less desirable than more general things when it comes to coding. One example of something that's particularly specific in this problem is the fact that I can only test for one dimension at a time, right? I can change the dimension. So if I want 3 words and 3 letters, I can do that. If I want 5 words with 5 letters, I can do that. But a better design, I think, would be, can I check for any dimension? So just check to see that the number of words is equal to the number of letters for each argument that came in. That's a much more general design, wouldn't you agree? And I think using this refactored code gives us a better starting point to solve that particular kind of problem, perhaps, than the way that we had it before. So that kind of changes things a little bit. If I'm not necessarily looking for a specific value, how does that, what code is that going to change? How is that going to change our code? What do I need to look at? Which function? So, I mean, basically, do you understand what I'm asking? So instead of saying 5, right, I want this to be any number. I want to allow this to be any number as long as the number of words and the number of letters per word match. Does that make sense? So what needs to change then? Yeah. No, not necessarily. I still want to use command line arguments. But Yeah, so my dimension is no longer going to be, this is kind of a magic number in itself, right? This dimension value is kind of a magic number in itself. I want it to be more general, so argc minus 1, right, is really my dimension, argc minus 1. Does that make sense as to what's happening? Count how many words they typed in, and now make sure that the number of letters matches that number of words. Does that make sense? Do we have to change anything else? I'm sorry? Well, yeah, the comments. Yes. We require the number of words, letters, something like that. What does also, make things a little bit tricky is this. These comments down here. Please enter X words. Well, that's no longer true. I don't necessarily want them to enter a specific number of words. I want them to enter a number of words that's equal to the number of letters in the word. So these messages also would need to change a little bit. Does that make sense? You understand why that's the case? So I would need to rewrite these. Enter. How do I say this in an efficient way? Please enter. I'm sorry? Words. So this one is actually testing for the number of words. Yes? Actually, yeah. So, sorry, I didn't mean to cut you off. Mm-hmm. Mm-hmm. Sure. Yeah, but the problem I'm trying to get away from is there's no distinct number of words that we want anymore. So telling them that we want X number of words or X number of letters per word is no longer true. I want that to be able to change based on whatever, as long as they're the same, the number of words and the number of letters is the same, I don't care what that number is. So actually, do we need this? This is no longer necessary, correct? Do I care how many words they entered in? I'm letting them choose how many words they entered in, right? I'm letting them choose that. So I don't need that anymore. Does that make sense why I don't need that? Think of it this way. Up here at the top, I set dimension to be argc minus 1. So why then would I bother checking argc again? I'm basically comparing argc to itself. Will that ever fail? It'll never fail, right? It'll never fail. So I don't need that check anymore. I still do need this check, right? I still do need this check, and I still do need to change this message to be a better description. So I'm still not sure. English, I swear I'm worse with English than I am with C. Yeah, please give me the number of letters in each word equal. This is okay. This is okay, right? It's accurate. It's accurate. Like I said, English, not my strongest suit. But now we have a program that is even more flexible than it was when we started, which from a programming standpoint is very, very valuable. So just to reiterate, oops, we did something wrong. Data argument 9. Oh, yep, I see what I did. So it says data argument not used by format string. This is another thing that I hope that you're getting more skilled at is interpreting these awesome error messages. So it says data argument not used by format string. I look at that, it tells me there's a problem with this line. I remember that, oh yeah, I had this out here, but I don't need it anymore, right? I don't need it anymore. So I just need to take it off. All right, now it compiles. And now I'm saying that this should work, right? And it does. But I'm also saying the original example that we used with 3-letter words should also work, correct? So this should also work, right? And it does. So now it's more flexible than even the way that we described it before. That's a great thing. That's good design. Yes? Mm-hmm. So, like if I break it somehow, I can come take a look. I can come take a look after we're done here and see. But we are running out of time. Are there any questions for me before I wrap up? Yes. Yeah, so the question was, is it good practice to return 0 at the end of the main function? That's done for you. If you don't say it, it does it for you automatically. That's one of the few things that it will do for you automatically on your behalf. Can you say it? Sure. It's not a big deal to do that. Good question. Any other questions? Yes? It sure does. The return type for main has to be int. The compiler gets mad if you try to do something else, I believe. Sure does. That integer is kind of a status code, where 0 it means everything went perfectly fine, and any number other than 0 means something bad happened along the way. I have a couple questions for you before I wrap up. I'm interested in what you guys are working on right now. So how many of you are still working on the problem set for Module 3, the magic square? All right. How many of you are planning to work on the studio from Tuesday, word grid stretch right now? Very few, very few. How many of you are planning to work on today's studio right now? A lot of you. All right. Excellent. So I saw a pretty significant amount of people working on still working on the magic, the 15 puzzle, right? That thing. So I would just like to make sure, the reason I asked is because I wanted to make sure that we use our mentors and myself effectively. So here's what's happening now. There's going to be another advanced topic in the classroom for those people who are interested. It is on, Mike, remind me what it's on again? Okay, so operating systems in Linux is the topic, the advanced topic that's going to be starting in the classroom right now. For people who are working on PSET 3, especially, I think it would be good, you know, if we could get a group of people together and maybe stick some mentors on that problem and help people figure that out. So if you all want to congregate somewhere, preferably somewhere near a whiteboard, maybe in this up front section, up here to my right, up front, I'll make sure that there are some mentors in that section, in the front right section over there by the whiteboards, by the booths, that can help people out with PSET 3 specifically. If you're working on ASCII art, which looks like a lot of you, we'll be circulating as normal. And of course, if you're working on anything else, we are happy to help you. I just want to make sure that we allocate our resources effectively. Yes? Yeah, so studios, since we have people working on various things, having the studio submitted on the day that it's assigned is becoming less and less important. So basically, don't worry about it. We still want you to do the studios, we still want you to submit the studios, but getting it submitted on the actual day is not as important anymore, I would say. So focus on whatever you need to focus on. If that's the studio, awesome. If it's something else, then awesome. Yep. Question in the back. Mike would be the one who knows the answer to that. I personally do not know the answer to that question. You can ask him. I think he's actually in the classroom right now. I don't know. It's a good question, though. Yes? Of course. Yeah, of course. Absolutely. All right. Yeah, let us know if you need any help with anything. Thank you.